So effectively held in direction in the XX axis. So in the XX direction, for buckling about the Y axis, in my opinion, that means it is pinned top and bottom X axis. So it can fail like this. So here's a little diagram. So we're looking at XX, which I've drawn like that way. So what basically this is the B, this is the beam. I've drawn it like an I-beam, but it's actually more like an H, isn't it? 203 by 203 times 52. It will buckle about this axis. That means that basically, as I've done another diagram below, but if it buckles about the XX axis, that means I found it easier to think of it as all the deflection will take place on the y axis. That's at 90 degrees to the XX axis. Just think of it like that. So if it buckles about XX, that means it deflects about y. It deflects about 90 degrees. So like this. So for the so I can do it with a ruler, and also here's a little chance to look at how good things are at resisting buckling, because this is a column, right? So you've got flange, web, flange, and then I've separated those things into the three parts. So you've got flange, web, flange. We're talking about buckling against the XX axis. So if you look at the flanges, they are at right angles to the they are parallel to the axis of buckling. So that means that when you do this, it's easy. It's going to buckle. It's weak because BD squared about that axis is the least. So it has very low moment of inertia about that axis. So it just bends. So the flanges for this section, the way it's orientated about XX, the flanges are going to be weak. The thing that's going to do all the work is the x-axis, because if you turn this at 90 degrees now, I try and buckle it about, I can't do it. It won't buckle about the other direction. So that's because the BD cubed is much bigger. Oh yeah, and basically the other thing was to think about was the maximum deflection should if everything's symmetrical, should take place at h/2 with the maximum deflection. Here's the axial load. The maximum deflection will take place at midspan. So the above isometric 3D, that's an example of how the column will buckle. To show the orientation of when it says buckling about XX, that means maximum deflection along the y axis. So the plane of the bending, that's what I'm talking about, the planes of the bending. And to demonstrate which part of the UC is strongest, so the flanges are weak about XX, but the web is very strong about XX. So then I've done here, so there's that diagram, that's an isometric, and then I've done this diagram. This is dy, displacement deflection in the XY plane. So I've done a cross section basically. All I was trying to show is again how it buckles. So basically this is dy along the x-axis is coming in out of the page. Dy is the maximum deflection. So go back to the ruler again. So it just bends like and with the maximum deflection on of dy at h/2. So basically, the other most important thing was to say was, so when it says held in position, for me that just means it's pinned. It's held in position, but it's not. The column can move in any direction. The top of the column can rotate basically like that. So basically, it will just buckle between those 2 points. So therefore, for held in position but not restrained in direction in the x-axis, therefore LE equals 1 times L. So that's 6 meters. So LEX is 6 meters. I just did a bit more drawing here. That wasn't actually, so that is the answer to the question. I just did a little bit more. I was trying to think about it as like, on the right hand side, this is the elastic. This would be elastic deflection, and then this would be like failure. Then it would just go, this would be like plastic deformation when the column just buckles totally. But that's for another video. In this case, LE equals 1 times L, which is 6 meters. So I'm just gonna do the buckling about the Y axis in a separate video. But hopefully I've covered the most points. The main point was when it says held in position, for me that just means it's pinned. When it's pinned, LE equals 1, so LE equals 6 meters. So that's half of the marks for this question. And then as you just saw, I just tried to explain the planes of buckling so people could understand. When it says buckling about XX, that means deflection is about Y. And then I did break the column section into 3 parts so you can see which parts are the strongest about this axis. So in the next video then I'll show you it's getting a bit long now, this video, and it's easier for people just to say if they want to do XX and then look at the next video YY. So in the XX axis the column is pinned. So hopefully you found that useful. Please like and donate to the channel. Please like the video, subscribe and donate to the channel if you can, just so I can keep on making more videos. Hopefully this has been useful. Thanks for watching.